We missed the first thing of your year 12 being recorded, but we'll record the rest of it, hopefully, and then you guys will be able to access that. So, okay, now we need to talk about basically the opposite of that. What happens when we're given a vector in 2 dimensions and we want to break it down into simple vectors that we can understand and calculate resultant vectors from? So this is called vectors resolving into components. Exactly. Those components in particular are, of course, horizontal and vertical components. The reason we use horizontal and vertical is they're, conventionally the 2 different dimensions we can deal with. If we isolate everything into those horizontal and vertical components, then we can compare everything against horizontal and vertical components. And one-dimensional math is really easy math. Yes? Say again? What form? No idea what that is. Probably not. Well, that's what our resultant vectors is, isn't it? I don't know. We'll find out. We'll find out. So let's just jump into an example because I think it's clear that this is the opposite, right? So when given a vector with 2-dimensional or with 2-dimension components, we resolve it into horizontal and vertical. For ease of analysis. Much easier to deal with them once they're in horizontal and vertical components. There are some really complicated problems that come up with interactions through electric fields and things like that, forces applied by electromagnetism and stuff, and they are so much easier to deal with when we break our vectors into their component forms and analyze each horizontal or vertical component separately. Trust me. So, for example, let's call this force in newtons, some force, okay? It's at 32 degrees to the horizontal. And it has a magnitude of 22 newtons. Okay, some force being applied to some object. So this is a typical example if you are pulling something with a rope or, with your arms, really. You generally are applying a bit of a force upwards, even if you're trying to pull it across the floor. And that's logical because you often want to reduce friction as well when you're dragging things across floors. So you lift them up a little bit and that actually reduces friction. It also prevents the leading edge from getting caught on anything. But anyway, if we want to break this down into horizontal and vector components, we are looking at, let's do pink and purple. Horizontal. Let's draw a quick triangle. Label our known information. Identify our angle theta. And this is our horizontal component fx. Okay? Still a vector, just a one-dimensional vector. Much easier to deal with. We have set this to be a right angle. We know that to be the case. We don't know what this is and we don't care. Until now, where we look at our vertical. Same triangle, and hopefully on your diagram it actually looks the same rather than my diagram where it doesn't. But anyway, 32 degrees again. Only difference is, instead of looking at that horizontal component, we're looking at our Fy, our F vertical. Right, logical setup for our problem, resolving into components. Let's break the problem up into our components. Do you have to draw the diagrams each time for both? No, you could draw a combined diagram. You could just annotate the diagram you're given. That's reasonable communication. But it does make things a lot easier, and some of these problems will get really confusing and complicated, and there'll be other forces at play that you're analyzing. Much easier to break it up. Okay. Was that a question? Yep. I don't mind if you use... No, the fx and f, not required. You don't have to use that notation. Yeah, maybe call me over and get me to check it when you're doing your own exercise, but I'm sure it's fine. Yeah. Okay, now we're just going to use trigonometry here, okay? So in this case, we've got a hypotenuse and we've got an adjacent side, adjacent next to the angle. So we're going to use A and H, so toa, go back to cos theta equals A over H. Oh, I was meant to do these in separate colors. Oops, that was meant to be purple. This one was going to be pink. Anyway, it's all pink. Yay. The cos theta equals A over H, or in this case, we bring that H across, multiply both sides by H. H is actually our force that we're given. So F cos theta equals F of X. And you will do something like this time and time again. Cos if they're adjacent like that, sine if they're opposite. So same thing over here. F sine theta will give us our Fy. We'll hopefully get to a stage where I don't have to remind you of what I'm doing with the trig there and why it's rearranged. But for now, while we're just being introduced to it, I'll try to make the effort. If at any time I do stop explaining that and you don't know how I did it, please stop me and remind me, because you need to remember it for your exams, right? So just get me to remind you when you forget it, then and there, and just enough times of remembering it, you'll probably remember it forever. Okay, so fx equals f, which is 22. Cos of theta, and theta is 32. And that gives us, plug it into your calculators, let me know. That's the horizontal. Sorry. 18.66. Problem was given two significant figures. Let's say 19. Vertical, which was meant to be purple. I'm so upset. Purple problem. Oh, that's hard to read, isn't it? Okay. This is the purple part. Oops. So Fy will equal 22. Sine of 32. That's the only thing that changes. And the answer is? Voila. Resolved into component vectors. You should state somewhere the direction of those vectors. They're one-dimensional, but they're still one's going one way, one's going the other. But I've done that by establishing at the start that this is horizontal, this is vertical, right? So as long as you establish which one's which, you've communicated that sufficiently. You don't need to give me an angle or anything like that. You don't need to say downwards. If the thing's then used later to establish which direction it's going, then you should talk about positives and negatives. All right, all good? Do an exercise. I'll leave that up for a second while I grab your exercise. Sorry, did anyone still need that? Nope, cool. Have a go at this. Get you the picture as well. Oh, never mind. The picture's literally, it's not helpful. It's a guy shooting a bow and arrow. You don't need that.